Okay, question 12. The diagram shows the front view of a garage. Calculate the length of the sloping edge of the roof. Do not use a scale drawing. So first of all, we are going to create a right angled triangle as shown by the red line. So there's a right angled triangle. Now we need to fill in some sizes. So our base is 3.8, but what about our height? So in this case, we can see that the length there is 2.9 and the length there is 2. So the difference between them will be 2.9 minus 2, giving us this height here of 0.9 metres. So now we have a right angled triangle and we know two of the lengths of the sides. What could we possibly use in order to find the third side? And it's going to be Pythagoras. So we need to find the longest side, as it's the side directly opposite the right angle. So Pythagoras' theorem says that a squared plus b squared is equal to c squared. And in this case, c is going to be our longest side. So 3.8 squared plus 0.9 squared is equal to 15.25, which is equal to c squared. But I don't want c squared, I just want c. So we need to undo the square by using the square root. So c is equal to the square root of 15.25, therefore c is equal to 3.9051 ... Do that to show the unrounded answer, and then if you're not told otherwise, round to 2 decimal places. So our final answer is c equals 3.91 metres to 2 decimal places. So question 13. In a jewellery shop, gold chains are displayed diagonally on a square board of side 20 inches. The longest chain stretches from corner to corner. Calculate the length of the longest chain. Do not use a scale drawing. So we've got a right angled triangle. Going from the information in the question, each of our shorter sides are going to be 20 inches. So 20 and 20. There's our right angle straight across. That is what we want to find. We'll call it C. It's the longest side. We're going to use Pythagoras. So c squared is going to be equal to 20 squared plus 20 squared. So c squared is equal to 800. Again, I don't want c squared, I want c, so I'm going to have to use the square root to undo it. So c is equal to 28.2842 ... Always give the unrounded. Again, we're not told what to round to, so I'm going to round to 2 decimal places. So the longest chain is equal to 28.28 inches, and that's it done. So question 14. A rectangular shelf is supported by brackets as shown. Each bracket is a right angled triangle. Calculate the width of this bracket. Give your answer correct to 1 decimal place. Do not use a scale drawing. Now, as you can see with this one, yes, we have a right angled triangle, but this time we are giving an angle. So we're going to be using SOHCAHTOA trigonometry to work out our missing side. So the first thing we're going to do is name all our sides. Find the right angle, go straight across, and that is our hypotenuse. Find the angle, go directly across, and that is the opposite. And the one that's left is the adjacent. So we're going to use SOHCAHTOA to decide whether we're going to use sine, cos or tan. So in this case we have the adjacent, so tick off your A's. And we want to know the width, which is the opposite. So tick off the O's. So the one with 2 ticks is tan. So that's what we're going to be using to solve this. So filling in the numbers from the question, the tan of 53 degrees is equal to the opposite divided by 14. We now need to rearrange this. So 14 tan 53 is going to be equal to the opposite side. We put this into the calculator and we get 18.5786 ... Now this time we have been told to round to 1 decimal place. So that will round to 18.6 centimetres. Question 15. In a school hall, the stage is lit by a spotlight fixed to a wall. The spotlight is 4.35 metres up the wall and is set to shine on a spot on the stage 5.2 metres from the wall as shown in the diagram. Calculate the size of the angle marked X. Do not use a scale drawing. Now again, we're looking for angles, so we're going to use trig. So directly across from the right angle, we have got our hypotenuse. Directly across from the angle, we have our opposite. And the one that's left is the adjacent. So katoa to decide what we're using. So mark off what we know. So we know the opposite, so we can tick the O's. And we also have the adjacent, so we can tick that off as well. So the only one that's got 2 ticks, again, is tan. So that's what we're going to be using to find it. So the tan of x degrees is equal to 5.2 over 4.35, the opposite over the adjacent. So in order to rearrange this, we're going to have to use the inverse, the little -1. So that means you have to press Shift tan and then 5.2 over 4.35 and hit equals to get your angle. So x is equal to 50.0862 ... We're not told what to round to, so I'm just going to round to 2 decimal places. So our answer to 2 decimal places is 50.09 degrees. Question 16. PQRS is a rhombus. The diagonals PR and QS are 15 centimetres and 8 centimetres long as shown. Calculate the length of side PQ. So there is PQ, this side here. So these lines show that those 2 lengths are equal. Likewise, that and that. So we've got a right angle triangle yet again. And we are going to use Pythagoras to find our missing side. So our right angle triangle is here. So now we just need the lengths of the sides filled in. So looking from the centre to Q, that's half at 8 centimetres, so it's 4. And looking from the centre up to P, it's half of 15, which is 7.5. Now again, we're going to use Pythagoras' theorem. We can see that the side that we want to find is opposite the right angle, therefore it's the longest side. So we'll call that C. So C squared is equal to 7.5 squared plus 4 squared. Therefore C squared is equal to 72.25. But we don't want C squared, we want C, so we need to undo it using square root. So C is equal to the square root of 72.25, which is 8.5 centimetres, and that's done. Question 17. The sketch below shows the ramp at the back of a removal van. The ramp is 2 metres long and is fixed to the van 0.8 metres above the ground. Calculate the size of the angle marked X. So we have a right angle triangle, and we have been asked to find an angle. So we're going to use katoa in order to determine whether we're going to use sine, cos or tan. So in order to do this, we need to name our sides. So first of all, we look at the right angle, go straight across, and that's our hypotenuse. Next, we look at our angle, go straight across, and that's our opposite. And the one that's left is the adjacent. So now we're going to tick off what we know and what we want to know. So we know the opposite, so we can tick off the O's. And we also know the hypotenuse, so we can tick off the H's. So the only function with 2 ticks is sine. So filling in our information, sine x is equal to 0.8 over 2. But of course we want the angle, so we're going to have to use the inverse function of sine. So remember, shift sine, and then 0.8 over 2 is going to be equal to x. Therefore x is equal to 23.5781 ... We've not been given what we've to round to, so I'm going to do it to 2 decimal places. So that's 23.58 degrees to 2 decimal places. Okay, question 18. A rectangular picture frame is to be made. It is 30 centimetres high and 22.5 centimetres wide as shown. To check that the frame is rectangular, the diagonal D is measured. It is 37.3 centimetres long. Is the frame rectangular? Again, we've no angles, and we want to prove that something is a right angle. So Pythagoras can not only be used to find missing sides, it can also be used to prove that something is a right angled triangle, as it will only work if it is a right angled triangle. This is known as the converse of Pythagoras. So first of all, we take our two shorter sides, we square them and we add them. Our answer is 1406.25. Next, we take the longest side, the diagonal as it's been measured, and square it. So 37.3 squared is equal to 1391.29. Now, as you can see, the two sums are not equal. And we write it as such. 30 squared plus 22.5 squared is not equal to, it's an equal sign with a line through it, is not equal to 37.3. Next, you've got to get the wording really accurate for this. So this is how it should go. By the converse of Pythagoras, this is not a right angled triangle, therefore the frame is not rectangular. You have to answer what you've been asked. Okay, question 19. A triangular paving slab has measurements as shown. Is the slab in the shape of a right angled triangle? Show your working. This is another converse of Pythagoras. We are going to use Pythagoras to prove whether or not this triangle is a right angled. So we start off by finding our two shorter sides, squaring them and adding them. So 90 squared plus 60 squared is 11,700. Then we take the longest side and square it, so 110 squared, which is equal to 12,100. Now as you can see, they are not equal, therefore it is not a right angled triangle. So again, 90 squared plus 60 squared is not equal to 110 squared. So the wording is important. By the converse of Pythagoras, this is not a right angled triangle.